This is FLOSS Weekly. I'm Doc Searls. Shawn Powers and I will be talking this week with Phil Windley about the Internet of People and Things. There's a lot going on across all of that, and it's new, and that's coming up next.
Podcasts you love.
From people you trust.
This is TWiT.
This is FLOSS Weekly, episode 610, recorded Wednesday, December 30th, 2020. Internet of People and Things. Hey there, everybody. I'm Doc Searls. Welcome to FLOSS Weekly. Back for the last day of 2020, one of our worst years ever as a culture and everything else. But and my co-host this week is Shawn Powers. Hey there, Shawn.
Hey.
There he is. His blurred background and everything. Where are you? And how's it going?
So the standard Michigan map is a hand, and I am at the tip of the pinky finger, and it is snowy and cold, and I'm ready for summer. For so many reasons, I'm ready for summer.
A little north of Traverse City, then I guess, and
Exactly.
Inbound from the dunes, and yeah, beautiful country. I've seen it in the summer, and not in the winter. I am in Santa Barbara, where we don't have snow, and we actually don't have weather. We have a climate. This is the rainy season. We had a gigantic rain a couple of days ago, and a gully washer, and now it's done. We're done for the year, and the fire season starts in a couple months. And
I was going to say it's better than last time. Last time I was talking to you, there were like fires out your window and stuff. So,
yeah,
I mean,
there are not fires here. The sky is completely blue and clear, and there we are. So, have you done your homework? You know what Phil Windley's about, and what?
Yes. So I read blog posts and websites, and I thought I am going to know all of this stuff. I think I might be dumber now after reading all this stuff.
Phil,
I failed.
Phil will clear that up for us. So Phil's here, I know, because we saw it before the show. There he is, Phil. So Phil, where are you? I know you're not at BYU.
In Island Park, Idaho, which is just outside Yellowstone. We came up here for the holidays, and then unfortunately that means I'm without all of my normal gear, so I'm using kind of a makeshift mic. I hope it sounds okay.
Yeah, so I'm by way of introduction, Phil, I have to run this down. Phil's an old friend, but he's a Navy veteran, an officer in the U.S. Navy, served on submarines. He's got a computer science PhD. He's a serial entrepreneur. He's the former CIO of the state of Utah. He's been working at Brigham Young University for quite a few years as well, where, among other things, he runs Pico Labs, or is involved with Pico Labs there, which we will talk about. He was the chairman of the Sovereign Foundation, that's SOVRIN, which is a homonym of the sovereign and self-sovereign identity, which we have covered in the past on this show, for example, with Brian Bellendorf and Kalia Hamlin. Kalia, Phil, and I together put on the Internet Identity Workshop, which has gone through 31 or 32 of those so far, twice a year, a very successful unconference, an open space unconference. But most importantly, I think, and if I were to try to summarize this by way of introduction, were I young enough and motivated enough, out of all the possible things one could do in the world, I would start a business around Picos and SSI. So without any further delay on that, let me bring Phil in and ask him. So he just wrote a piece. He just wrote a blog post on the generative self-sovereign internet. And in fact, wrote it after he and I prepped for this show, if I'm not mistaken, in which you're saying, Phil, that it's a secure overlay. I'm going to read from the summary. A secure overlay on the internet that provides the same capacity to produce change by numerous unaffiliated and uncoordinated actors as the internet itself. And it's underpinned by the same properties that make the internet what it is. So what is not generative about the internet we have so far that it needs an overlay of some kind?
Well, I think if you look at the internet itself, just what we typically think of as the internet, it's very generative. In fact, you are well aware of Jonathan Zittrain's 2005 paper on why the internet and the millions, billions probably now of connected PCs represents a significant generative ecosystem, meaning that lots of different people can just do what they want. It goes back to your and Dave Weinberger's, I guess they were virtues of the internet, is what you called them, that nobody owns it, everybody can use it, and anybody can improve it. And that's what Jonathan meant when he talked about the generative internet. But what's happened over time is we now think of, if you just go out on the street and say, hey, what's the internet? People think of the web, which is not as generative, I think, as people had hoped in the 90s that it would be. And that's primarily because Web 2.0 came along and turned HTTP into a way of delivering services for big companies. Your famous, calf-cow argument about how web servers essentially, give us cookies and milk, and we'd get to just take whatever they give us. And that's not generative in the sense that, it is true that anybody could stand up a web server and build an API or whatever. We've gotten to a situation where almost every interaction we have online is intermediated by some big company. And that wasn't how TCP was set up, right? TCP is a peer-to-peer protocol. And, we were talking as we were setting up the show about email. And while it is true that most people access their email through a client-server protocol, IMAP, the email itself is going between places in a peer-to-peer fashion. And there are, store and forward mechanisms and other things that make that all possible. But, we think of one email server sending the email to the other email server, and then some client accesses it. So that's, I think, where we've gone wrong, is we've gotten into this situation where normal people are always intermediated by somebody else with their own purposes and their own reasons. And so getting to a self-sovereign internet really means that we get back to the internet the way it was envisioned, as this, peer-to-peer relationship-based interaction without intermediaries.
So you had one time the best one-slide presentation I'd ever seen, and it said, History of E-commerce, 1995, invention of the cookie, the end. And we're still there. I think you did that in like 2007 or something like that.
Oh,
and,
yeah.
And what you meant by, what I meant by calf cow, David Weinberger and I with that is that, basically client server, and I've heard this before, basically was chosen as a term, as an expression, because slave master didn't sound so good. And we call that calf cow because we're always the calves, and we're going to the cows of websites and services for the milk the milk of HTML and cookies, and that's where we're sort of not so much stuck right now as sort of we've sort of rationalized living in that world. So what is it about? I mean, we've talked about, actually had Devin Lafredo, who invented self-sovereign as a term on the show earlier on, back in May or June, though he mostly talked about education, I think, at that time. But tell us a little more about what to be self-sovereign on the net means, and what it is about SSI and DIDs, which are distributed identifiers. And there's a lot of work going on this right now, all over the place. And I mean, yesterday I decided that the Project VRM Twitter should follow a lot of people doing SSI. Over half of them were German, and it was in German. And I can read some German, so I understood it. But it tells me there's an awful lot of going on out there. So give us a sort of high-level summary of what SSI, what's going on.
Yeah, so if you, I like to say that Descartes didn't say, I have a passport, therefore I am. Descartes said, I think, therefore I am. And, I think the same thing is true of us today. We don't exist because someone gives us an account on their server. The term we use for that is an administrative ID system. So Amazon runs an administrative ID system. Google does. I mean, every website you use that asks you to log in is using an administrative ID system, meaning that they're administering it for their own purposes. And there's nothing wrong with that as far as it goes. You can't imagine, you don't have to imagine. There are all sorts of nefarious things that can happen on top of that, but nevertheless, companies have to have administrative ID systems. But where we've gone wrong with that is it means that online we don't exist except as something inside someone else's system. And there have been a lot of effort, a lot of projects that have tried to overcome that situation and create a situation where someone can exist online without having to be part of someone else's administrative system. In my opinion, they've all failed because they didn't start low enough. They didn't start basically at TCP and build up from there. And so what we can get into lots of technical details about decentralized identifiers, so-called DIDs. And by the way, make sure that we're talking about decentralized identifiers, right? The identifier, not decentralized identity. That gets used for lots of different topics. But decentralized identifiers is a standard. Like you say, there's a lot of activity around it. And the reason it's interesting, in my opinion, is because of a few things. One, because a decentralized identifier is bound tightly to a set of public keys, a public key, and yet allows that public key to be rotated without having to change the identifier. What we get is a situation where a lot of the problems with digital key management can be solved more easily using decentralized identifiers than they could in the past. So we get a asymmetric cryptographic system that is usable by regular people. So the software can manage almost all of the situations. People don't need to see keys. They don't need to manage keys. So what do they see? They see relationships, because once you've got these decentralized identifiers and you can exchange them, now you and I have a cryptographic relationship. And I think that that people think we build identity systems to manage identities. We don't. We build identity systems to manage relationships. And DIDs allow us to create these relationships, and at the lowest level, right on top of TCP. Not inside HTTP, not in someone's administrative server, but right there at that basic level. And because of that now, you get this mesh of connections that are cryptographically sound and self-certifying, which is another important feature. What that means is that you don't need the administrator to say that this is a good key, right? You and I exchange keys, and we're responsible for that, or our software is really. But the point here is that we create a overlay network, a secure overlay network right on top of TCP. And people have built overlay networks before. There are many of them. Maybe the most widely known overlay network is the TLS digital certificate system that we use on top of websites. It is an overlay network, and it uses cryptography to be secure. What it doesn't do, however, is it doesn't go both ways, right? Client certificates never caught on. And so it's just one side of the relationship. And second, because it's built on HTTP, a request response protocol, it's not as general purpose as a general messaging protocol. So by pulling this down and building this secure overlay using a cryptographic system that allows keys to be managed easily and doing it right on top of TCP, we essentially create what I've called the self-sovereign internet, because we don't need anybody else. We don't need any third-party administrators to allow us to use and build this. Now, the one final piece of this, which is important, is that the DID connection uses a messaging protocol called DIDCOM, which allows protocols to be built on top of it in the same way that TCP allowed protocols to write on top of it. So in the same way you get this, TCP or really IP at the neck of the hourglass in the so-called internet, hourglass, and then this fanning out of all of these different protocols like SMTP that we were talking about, or even HTTP. On top of that, you can do that same thing on top of DIDCOM. DIDCOM allows many different protocols to be built on top of it for many different purposes, and yet they're all running on top of this secure mesh.
So part of my homework was understanding the concepts of what you're talking about, and it's awesome. My fear is that the idea of a decentralized identifier, it sounds like everything is peer-to-peer, which is not a bad thing. It breaks that dependency on server-client relationships. But right now, my job has to do with IPFS, the Interplanetary File System, where files are stored not in a location, but by an address. One of the issues that we're running into bringing this into the real world is that it's peer-to-peer, and most companies have an inherent fear of anything peer-to-peer not controlled by a server. How do we go about that, whether it's an educational way or how do we fix that notion that anything not controlled by a central place isn't inherently evil, right? We're not all doing nefarious things in the background, because all of this conversation is awesome and exciting, but at the same time, I want to make this happen, and there's real roadblocks like that, and I don't know the first step to go make that better.
Yeah, so that's a great question, and one obviously that people in this space wrestle with a lot, right? Is how do you make this happen? And I think we just said, okay, we've got these DIDs, and you can create connections with each other and message back and forth, and it's all secure. That's cool, and techies might like that, but in the end, it doesn't necessarily, like you say, compel a company who would maybe be a little bit afraid of this technology of adopting it for something. So you need a Trojan horse. Maybe I shouldn't say that word, but you need a Trojan horse that you put on top of it, that companies say, hey, that's cool, I want that. And then you go, oh, well, you need this other thing in order to make that work. And they go, oh, okay. And that Trojan horse is verifiable credentials. So I mentioned that on top of this mesh, you can write lots of different protocols. One of the protocols that people are working on is one for exchanging verifiable credentials. Verifiable credentials is another W3C specification. But the exchange of them was not part of that. And we could get into all the standards wars that lead to that kind of thing. But nevertheless, the exchange that I'm talking about specifically is the one that is embodied in the Hyperledger Aries open source project. And there is a DIDCOM standard, and there is a standard for verifiable credential exchange on top of DIDCOM. What verifiable credential exchange does is it allows people to exchange credentials that work very similar to how credentials work in the real world. And so now you go to a credit union, and this is not something I'm making up. This is a real live use case. And you say, hey, credit union, you could create something called Member Pass. That's the actual name of it. And using Member Pass, your members could have a credential that they carry on a wallet in their phone. And whether they come into the branch, whether they call in on your support line, or whether they come to your website, you can use this Member Pass credential to know that you're talking to Phil Windley, who owns certain accounts, and that all happens using all of this great cryptography. And the techies nod and say, yes, it is great cryptography. That's really good. And so now you've got a business who wants credentials saying, okay, well, yeah, we have to have a DID infrastructure, and we've got to have something for managing our connections with people. And, in my experience, that doesn't come up. They don't say, oh, that looks really scary. They say, we really want the verifiable credentials. So I think that's the way you get past that, is you offer something that is so useful and interesting that people can't help but want it.
Translate that a little bit to the ordinary and the way that we interact with the world, because you're saying earlier that the model here is actually how we already do identity in the physical world, which is, I've got a wallet. If somebody wants to know if I'm over 18 or I'm licensed to drive or I'm a member of Costco or some other thing, that's what our mutual friend and the former chief architect of identity at Microsoft, Kim Cameron, wrote in one of his laws, which is minimum disclosure for constrained use, right? All you need to know is I'm over 18. All you need to know is that I belong here. All you need to know is something. You don't even need to know, it doesn't even have to be my real name. In the case of the credit union with MemberPass, what MemberPass does is a bunch of credit unions that are involved in this self-sovereign identity movement. It's just a way to, a member of a credit union can say, hey, I'm a member. That's all you need to know, right? And and that's, that in the real world, generally you're not looking for somebody's ID in the sense that I exist only as a driver in California, or exist only as somebody who has a passport. Even with a passport, all you need to know is that somebody is, say, a citizen of this country and isn't in trouble, and the passport officer looks at that. They don't care. They're not going to remember your name when you move on. They haven't scanned it. They haven't, they have a record. They've got a namespace somewhere. But for you and me, for ordinary people, we need to be able to to minimally disclose in a very casual way, not who we are, but all you need to know. It isn't who I am. Most of the time I'm not anonymous.
It's what I am.
It's what I am. Okay, so that's so the pieces of this, it's sort of I'm just going to reflect back to what I think I'm understanding about this. Self-sovereign identity is kind of the overall category here. It relies on verifiable credentials and distributed identifiers. And there are a lot of companies involved in this right now. Like I said earlier, there are a lot of people in Germany working on this thing and other places. But for you and me, for regular folks, and especially for our listeners and the smaller number of people that are viewing this right now, how do they get involved? What are they doing? How do we make one of these wallets? I imagine that's an open source thing too, is it not?
It is. So the Hyperledger Aries project has the code that makes all of this happen. There are at least, you talked about the wallet earlier, which is what you use to hold. Well, the wallet performs two functions. One, it creates these connections, these peer-to-peer connections. And the second thing the wallet does is it holds the credentials that you've accepted from various connections that you have. There are at least 4 commercial wallet vendors right now, and they're mostly interoperable. And I say mostly because there are edge cases where they don't quite work together, and that's obviously a lot of activity inside the community is making that interoperability rock solid. But, we lived without browser interoperability for, around the edges for a long time. Those things come. But you think about that, you now can say, okay, I want to use MemberPass. You're not locked into some particular credit union's specific application for proving to that credit union that you're a member of the credit union, and you can't use it for anything else. You now can pick a wallet from a number of different vendors. You can accept your MemberPass into that, and you can reflect that back to the credit union when you call in to prove that you are indeed the person they think they're talking to. But you can also use it with your employer to prove information about your credit union account to your employer when you're signing up for your paycheck, or your direct deposit for your paycheck, or any other purpose that you particularly had for proving to someone that you had particular information or particular relationship with a credit union. Maybe you're buying a car or something else. So that's the idea, is that it's not the special purpose app that's sitting on my phone from the credit union. It's an interoperable and substitutable set of applications. And like you say, if somebody wanted to get involved, they could get involved in the Aries project and build their own wallet if they wanted. Launch a different wallet with whatever they think is important. And as long as it matches the protocol, it'll be usable by anybody who wants to.
So, okay, so you said there are these four commercial projects already, and I'm thinking, okay, say it's I mean, the way I understand it, okay, I have this virtual wallet. It may not even be called a wallet, but I have a collection of verifiable credentials. A verifiable credential is I belong to this club. I'm licensed to drive, other things like that. How does this? I see there's two sides to this where development needs to happen, and some development is happening already. One is what I have as an individual. That becomes as casual and easy to use and mindless as pulling something out of your back pocket and showing somebody the relevant part of it on one side, but also on the corporate side. You gave the example of Member Pass, which is something that the credit union category is already on the case. Like SSI, self-sovereign identity, is partly developed there. How does the DMV at a state level get involved with this? How what's the tipping point? I guess what is going to make the tipping point happen, where the internal part of an enterprise, which is busy thinking, we have the namespace that's the orthodox namespace, and you have to be in that namespace, is the old way of thinking, and the new way of thinking is we have an appetite for verifiable credentials that minimize what we need to know about this person who just showed up. We just need to know they belong here. We're Costco. Yeah. You walked into Costco. We didn't have to have a guy at the front door. Maybe it's Bluetooth. Maybe it's some other thing that says this person is a member of Costco. But it's happening in a verifiable credential way, not in somebody looks at something they pulled out of their wallet way. What happened? How does that happen?
Yeah. So you had a couple. Your questions made me think of a couple of different things. One, just going to your last question or example about Costco or something else, and your earlier discussion of minimal disclosure. Excuse me. When you go into Costco, the only thing they really care about is that you're a member, right? You flash the thing, and it's not like they look at your picture and take down your name or anything else. And that's an idea of minimal disclosure. So let's say you had a verifiable credential, which represented your Costco membership. One of the things that could happen as you go through is that you create an ephemeral relationship with whatever device is at the door. And that using that ephemeral relationship, you prove that you are a Costco member and nothing else. They don't know your name. They don't get a picture. They don't get anything else. So minimal disclosure. So the Costco verifiable credential might have a lot of information on it. The only thing you're going to prove is, and I say prove because the technology behind this is zero knowledge proofs. That's the specific piece of cryptography that's making this work. So that's why I say prove, even though that might be a little bit, that word may not sound right to some ears. So the only thing you're going to prove is that you're a Costco member. So that's the idea. Once you're through the door, the ephemeral connection goes away, and there's nothing left in terms of they don't remember, they don't have any information other than that a Costco member came in. Now, it is their system. They could ask for all kinds of information. You may decide if you want to go in there, you do want to disclose your name or whatever, but that's a different question. That's not a technology question. And it's an important question. But that comes down to the regulations and the social constructs we have around things. You've talked in the past, Doc. We've discussed this idea that when you go into your local coffee shop, they don't take your driver's license and make a photocopy of it. You give them whatever name you want because all they want is a correlation identifier, and then they deliver your coffee to you. Now they could, right? You could open up a coffee shop if you wanted and say, hey, we're going to make a copy of everybody's driver's license as they come through our line. It probably wouldn't be good for business. So that's a social norm that prevents people from collecting too much information. Online, it's been too easy for us to collect information, and people have just collected it because they can, or because, hey, they're sending me all this, I guess I better keep it all. I think in some ways information is becoming toxic, and so there's going to be more and more companies who don't want it. Another thought I had as you were going through your question was, how do you get this to happen? How do you jumpstart that spark? And the credit unions are one example of a particular industry with a particular problem that they wanted to solve using a verifiable credential. Another use case for verifiable credentials that is happening is one by IATA, which is the International Airline Transport. I don't know if it's authority or administration or association, probably association. Anyway, they're looking at verifiable credentials for things like plane tickets. Now, there's a completely different situation where interoperability is the foremost thing on their mind, right? They've got hundreds, maybe even thousands of vendors who need to have some standard around what an airline ticket is. And they have airlines that need to know this, and companies that produce tickets, companies that read tickets. There's a whole industry that needs some standard for doing that. And so IATA can create a schema and for a particular kind of credential, say an airline ticket, and then because it's all based on this interoperable open source project, you can now, imagine that everybody could have access, everybody with a smartphone could have access to a wallet, doesn't have to be from the same vendor, who can hold their tickets, and you can show up and some piece of hardware or software on the other end who understands the standard can read that ticket and ask for whatever information is necessary. Right, you can imagine in some cases, the only thing that TSA cares about, I don't work for TSA, obviously, but they want to know that you're flying that day, right, and that this is a valid ticket. That's the primary reason why you're showing them your ticket. And they also want another piece of ID, which is your driver's license. So you could imagine those things all working in concert. Once you get airline tickets in this, now all of a sudden, all of the people say, well, why can't I have a driver's license in this same system? Because now I can prove all of that in one fell swoop, right? I just say, okay, prove to TSA everything they need to know in order for me to get through, and that happens. So that's the other side of this, is that where you need interoperability, that drives the use of these kind of interoperable standards, because the cryptography is hard and they don't have to invent that. The software is expensive to build and they don't have to do that. And so they essentially get that entire cryptographic mesh, this secure overlay that we were talking about earlier, plus a protocol for exchanging verifiable credentials, for getting validated information, and they get all of that for free. So that's, I think, the thing that pushes this out.
So to go back to my initial question about, how to make this seem not nefarious, while maybe Trojan horse wasn't a great metaphor to use, I do like the idea to focus on the security of things, right? This is increasing security for people, not focusing on this is a peer-to-peer identity type thing. So anyway, that's there. But my next question is, we're talking about standardization and we're talking about protocols, but how do we avoid getting Member Pass and Costco Pass and Coffee Pass and Doctor Pass and, all of these different wallet solutions that are essentially doing the same sort of thing, possibly using like Hyperledger or whatever. But how do we avoid having 1,000 digital cards that we have to sort through our digital wallet to figure out where we are? Is there hope for a standardization of self-sovereign identity that we can use whatever platform we want, whatever wallet we want, and be able to prove that we are who we are, give the information that we want? Because I think while I see Member Pass, that's awesome. That's just like one more thing that we have to keep track of and all of that thing. So is there some hope for some sort of I don't even know what to call it, some synergy, which sounds like a good buzzword to throw in there?
There's a couple of things there that, one, there may be a misunderstanding. I might have led you down a bad path about Member Pass. It's not a wallet, right? Member Pass is just a credential that sits in a wallet that you have. So, I happen to have 4 different wallets on my phone because I'm interested in all of these things and I play with all of them. But you would pick one, just like you picked Safari or you picked, Brave or whichever browser you happen to pick. You just have one. Most people don't use multiple browsers. I know some who do, but most people don't. You just pick one and you use it because it's all standard. And the same thing's true. Doc might be using the ID Ramp wallet. You might be using the Trinsic wallet. I might be using the Esatis wallet. And we could all have Member Pass in our wallet, right? So we've just got one app on our phone. Now we've got multiple cards inside of that, the same way that you carry multiple cards in your wallet. Now, you mentioned thousands, and it is true, right? So, you think about all of the credentials, and most of us underestimate the number of credentials we have in our lives. Some of them that we use every day we keep in our wallets. Some we keep in file folders in a file drawer somewhere. Some we lock away in a safe deposit box, because they're title to our house, for example, because we don't use them very often and we don't want them to get lost. The same thing's true in this world. You're going to have lots of credentials for lots of things. Some might represent a ticket to the play you're going to go to next week. You're going to throw that in your wallet, categorize it as something you need to have handy for next week. And when you get to the box office, you're going to prove that you should be admitted to this particular performance. And then you're going to throw it away. You don't care about that credential, right? So it goes away. Others, like your driver's license, you're going to probably have in there forever. So you're going to categorize these and keep them close. The third thing, which is important to point out, is it's not like you show up at the box office and you open up your wallet and you now have to go through it and find the particular ticket that you need to prove that you're going to this play on this date. Instead, what the software does, what the protocol does, is it allows the box office to send you a message because you're going to create a relationship with them. In the case of the box office, it's probably ephemeral, just like the relationships we create at most of those places, meaning it goes away right after you're done with it. And you're going to create a relationship with them, and they're going to request. They're going to say, we need to see this particular ticket. The software is just going to pop it up for you, and it's going to say, hey, the box office wants to see that you see the credential that says that you're allowed to see this play tonight. Okay? You say okay, and you're done. So for the most part, the hard work of categorizing and knowing what to present where is handled by the software.
So is this more than just a collection of individual credentials? You say the software handles a lot of it. My thought in my head is every time I'm filling out a form at a doctor's office or wherever I might be filling it out, every time it asks for my social security number, I leave that blank. And then if they press me and they absolutely need it for whatever reason they can convince me, I fill it in. Is this the kind of thing where every credential has to be filled out, or is it is it pulling from a credential database or my identity to create these things? I realize everything's going to have slightly different information they need, but am I just going to have 1,000 copies of my information in various credentials in my digital wallet?
Well, whether those credentials have duplicate information or not kind of depends on who issues them, right? So you're not going to fill them out. You're not going to create, well, for the most part, you can self-issue credentials, but for the most part, someone's going to issue a credential to you, just like the state issues a driver's license to you, or the airline issues an airline ticket to you, or whatever, right? Someone's going to issue this credential to you, and it's going to have whatever information in it that they deem necessary, right? Whatever they need for their purposes. Now, what's interesting is, you go back to the TSA example that I shared earlier. You show up at the airline security checkpoint. They want to see two things. They want to see your driver's license, and they want to see a ticket. And like I said earlier, you don't open up your wallet and say, oh, let me see if I can find the ticket. Let me see if I can find my driver's license, and then, show those to them in total, right? What you get is you get a request from them that says the security checkpoint needs to see this information. And what you're going to see on your wallet is you're going to see, oh, some of this information is coming from the airline ticket, and some of it's coming from the driver's license. And you can just say, okay, or you can go through and, like you said, you can say, no, I'm not going to share my social security number with you. Now, that's a little bit out of bounds because the security checkpoint doesn't ask for your social security number. They probably already know it. But the point is that there are some situations, security checkpoint, they're going to ask you for information, and if you choose not to give it, you're probably not flying. So you're probably going to give it. Other places like the driver's license, yeah, they may ask for all this information. You're going to see in your wallet, hey, the doctor's office wants to see all of this. And it may be coming from 10 different credentials, depending on what you've got in your wallet and what they want to see. You can pick and choose. You can say, no, I'm not going to share my social security number with them, and then send the rest. And then it's up to them whether they accept that or not. And that's really, I think, that leads us to, I think, one of the great virtues of a credential-based identity system is no one's telling issuers what credentials to issue. They issue credentials based on what they need. No one's telling Shawn or Phil or Doc what credentials they ought to keep in their wallet. We're getting credentials and holding on to them based on whatever we think we want to have. No one's telling the verifier, whether it be the security checkpoint at the airline or the doctor's office, nobody's telling them what they have to have. They're deciding on their own what they have to have. And like you say, the doctor's office always asks for the social security number, almost never makes you give it to them. So that's an excellent example of where they're making their own decisions about whether or not they really have to have this information or not. You're making your own decisions about whether you're going to share that information or not. Both of you are free to do what you want to do.
So Phil, we've got about maybe 15 minutes left, and I want to get into Picos. But first, I want to ask if you can answer this briefly and simply. If it's possible that the SSI DID's approach can get rid of logins and passwords, because I think that's what's going to sell it if we can possibly make it
absolutely happen. I mean, that's table stakes in this game, right? If you're not getting rid of...
How is that table? That's a stake nobody has seen so far. It's like we assume, logins and passwords are stuck with them forever. Horrible, but it's...
I mean, it could happen two different ways based on how we've discussed it. One is I could just accept the fact that you and I have a connection, and think about it with reference to TLS or HTTPS. When you go to a website, you get a little green, lock or whatever in your browser that tells you that you're talking to the right URL, at least, right? That they have a valid certificate and that the communication is protected. They don't get anything from you. So now, make that symmetric. So now they know who you are and you know who they are. You don't need a password anymore. I like to think of this as the bat phone, right? When Commissioner Gordon picks up the bat phone, and Batman picks up on the other end, and obviously I'm dating myself by the Batman reference here, but when Commissioner Gordon calls up Batman, he doesn't say, can you tell me your mother's maiden name? What year did you graduate from high school? He doesn't need to. When he picks up the bat phone, he knows he's talking to Batman. Same thing's true of a DID connection. When you have DID connections and I talk to you over that connection, I know I'm talking to the person who controls the keys for the other end. Now, if you lost your keys, I may not be talking to you, but I know I'm at least talking to whoever holds the keys for that particular connection. So I don't need a login. I don't need a password. What I need is this connection. Now, I do need to, when I go to a website, I need to tell them who I am in the sense of this is the connection that we have established. And there are various ways I can do that. But once I do that, I don't need a password.
Okay, so I want to, that's good. I think that's a good tempting thing to hear. So for those of you watching this, you'll see that Phil has a telescope behind him. I have a reel-to-reel tape deck. I've got a Grundig radio. I have these headphones. I have this microphone. Companies made those things. Those things can have Picos. They can have an instantiation of themselves on the internet, in a cloud, that does not require them to be smart. And to me, the great invention, the great assumption behind Picos, which you invented, if I'm not mistaken, or you and maybe Sam Curran and a few other of your colleagues together did, but and you can run the credits any way you want. But the interesting thing to me about that is that we've assumed that the Internet of Things has to all be smart. But instead, they could be the smarts could be somewhere else. You could put a QR code or a barcode or some other identifier on there, scan it, say this is it, and it can have an instantiation that's programmable on the net. And in the limited time we've got, I'm hoping you can say enough about that so somebody's tempted to start a company around it, because I just think it's hugely. I mean, the internet. We don't have the Internet of Things yet. We have the Google of Things and the Apple of Things, and the Facebook of Things.
I call it the CompuServe of Things.
And yeah, you call it the CompuServe of Things, which I think is absolutely brilliant. because and it's as antique an idea as CompuServe itself was. We have the internet now. Everything should have an identity that's useful. For insurance, for selling it, for buying it, everything that's sold should have its own Pico, I would think. And then when you get around to selling it again, you can, in a minimally disclosed way, say this is here. It's a VIN number on the car. It's had this. Here's the repair record. Here's whatever else I want to say about it. So okay, so fill us in on what that is, because I think it's just huge.
So Picos are an actor model programming system, right, that is internet aware. And obviously we could talk for a long time about what all of that means. But tying it back to what we were just talking about, they're also DID aware, meaning that Picos create connections to other Picos and to people using DIDs, right? So they create these two-way cryptographic relationships. And because they have those DID relationships, they now are working on top of this secure overlay network that we discussed earlier. So they are, they're every bit as capable as a wallet in terms of the connections that they can make and the messages they can exchange over them and the protocols that they can accept. So I don't know if it's possible for Ant to maybe put up a few graphics, but I have one called oldmodel.png that if you could put up would be helpful.
Yeah, and for our listeners, you would walk us through it if it's there.
Yeah, I'll walk through it. Yeah.
I think Ant's probably looking for it. But
if we think about how the CompuServe of Things works, right, the current model, there is always somebody in between you and your thing. And there's been lots written about this. I'm certainly not the first person to have talked about this, but you don't own the things that you think you own, because in fact the intermediary could turn them off or do something with them at any point, right? If Fitbit decides that they don't like you and turns off your Fitbit account, you now have an expensive piece of plastic that you can set in your drawer. That's all it's good for. So that old model essentially always puts the company between you and your device. But now,
so the example just is you're not seeing it on screen, but I am. What you have is actually an example you and I have talked about. I have a coffee grinder. It's made by a company called Baratza. they have an API that's talking HTTPS to an administrative IoT service, and then Alice, who's me in this case, is able to talk to that. But that's the old model. That I have that right?
Yeah. No,
are we looking at the right one?
No,
okay, that's.
Yeah, exactly. That's exactly right. Now, if we could show ssiot.png,
there it is. It looks more complicated, right? But the important thing is that Alice, who's the owner of the actual thing, is sitting in the middle. She has peer relationships with other people, and there's a little wallet that she has. It contains those relationships. She has a relationship with an attester that which she has a peer did relationship, and with all these different players. So maybe you could unpack that for us.
Yeah. So Alice, like you said, has relationships with people. She has relationships with companies. But importantly on this diagram, she also has a relationship with a thing, her coffee grinder. And she also has a relationship with Baratza. But Baratza isn't sitting in between her and her coffee grinder. They're off to the side, right? And so Alice has this peer-did relationship, right? She is connected to the coffee grinder. Now, what does that mean? Well, it might mean that if the coffee grinder is smart, it might mean that she can use that to do firmware updates or to prove that she's the owner. We have talked about the fact that she could use it to do customer service. So in other words, she could do customer service through the coffee grinder. And as you pointed out, that works whether or not the coffee grinder is smart or not, because in fact, the coffee grinder could be shadowed, right? A digital twin, if you will, sometimes people call them, by a Pico, right? And so this Pico, for Alice's purposes, looks like her coffee grinder, except it's more capable because it has a connection to the company and to other people, and multiple people could own the coffee grinder and have a relationship with it. But Alice now has this direct relationship with her thing. A more interesting example, perhaps, is the one that's labeled fuse.png, which is about cars. Right. So now this diagram is actually showing Alice again, and she has a relationship with somebody named Doug, and that's because she just got done selling Doug her truck. And trucks are interesting. Vehicles in general are interesting because they are very complex things that have lots of different relationships. And so, the fact that Alice and Doug can create this peer relationship in order to consummate the sale, they can use their relationships with their credit unions in order to transfer money. They can have relationships with the DMV and with insurance companies and with the truck itself. In the diagram here, Alice has already done the sale, and so Doug has the owner relationship. It used to be Alice's. Now Doug has it. But you'll also notice that Alice has a shadow truck because she wants to know information the truck knew about the trips it's taken and its maintenance records and other things. So even though she no longer has the physical thing itself, she can have a Pico that represents the thing. Now, of course, it's not active in the sense she can't use it to unlock the truck or many of the other things that Doug can do with his Pico of the truck. But nevertheless, she can get all of the information she used to. For many purposes, it looks just like her truck used to, except now it's just a shadow. This is all kind of reminiscent of something that Bruce, not Bruce Schneier, Bruce Sterling talked about in his Shape of Things essay from probably 10 years ago. The fact that things can have online existences and even have those online existences when they are not when they're not in possession of the physical thing. Because like you say, Doc, it's I'm looking at the diagram. Like you say, Doc, it's not that the thing is smart itself, it's that it has a digital twin which is smart. Tying this back to our earlier conversation, these little wallets here are the Pico's wallets or Alice's wallets, and they are They're what are in the SSI world, they're known as agents, right? So the wallet is essentially the user interface for the agent. And what's unique about Picos is that Picos, like I said, are an actor model programming system. Each Pico is a smart agent that can be programmed by rules. And each Pico can be independent and unique based on whatever rules it has put in it. So Alice might have got the original truck Pico from the manufacturer who set it up for her, but she can transfer it to her own system. She can transfer it to some other hosted system because it's all interoperable and substitutable.
So, okay, I thought maybe Shawn had a question here, but just to go back to Bruce Sterling for a second, Bruce called that stuff SPIME, S-P-I-M-E.
Yep.
So if you look up
which was
SPIME,
a neologism for space and time.
Yeah. So, so tell us, because we got like exactly 5 minutes left here. Tell us about Pico Labs, and which you run or are involved with, and how people could possibly get involved with that, or make use of the code that's living there.
This is all open source. There is a Pico Engine which makes these work. We've run it on everything from, EC2 servers to Raspberry Pis. We have dozens of Raspberry Pis sitting around with Pico engines running on them that we do use for various experiments. It is all based on Node underneath. You program Picos in a language called KRL, which is a rule-based, event-based language. But like I said, you can there's a GitHub repository at Pico Lab. There's picolabs.io, which has links to the documentation and to the GitHub repository. And I'd welcome anybody to go and take a look, to contact me, to I'd be happy to do demos for people, whatever they want to see.
So, okay, so we've got 4 minutes left, basically. So we generally end this with 4 questions. The first of which is, are there any questions we haven't asked that you would like it if we had asked?
No, I don't think so. I think we covered most of what we talked about in the pre-show.
Yeah, since we have a tiny bit of time for it, I have a very brief story about Costco. The back of my Costco card, I don't have my wallet with me. I just want to show it to you. It has somebody else's face on it, and it's because I had loaned my Costco card, not the one that's a credit card, but the one that's just a membership card, to a friend of mine who just needed to get one thing there. And when my membership ran out, or when it was due for renewal, they said, this is an old card. And they looked at it and they said at the service counter, you need to renew this. And they said, this doesn't look like you. And he said, that was before the accident. And then they shot another picture of him. And that has been on the back of my card ever since. And he has died since then. And on the back of my Costco card is still a picture of my old best friend in Santa Barbara, who's now gone. So that it sort of tells you what's broken about the system we have. Okay, so
that was before the accident. I'm going to remember that line.
It's one of my great lines. I mean, that was before the accident. We don't look.
I used to look like
he had long, thick blonde hair. He looked like Hugh Laurie, the actor Hugh Laurie, very similar. I mean, it's nothing like each other at all. Anyway, they were born in the same month and within miles of each other, it turns out. Anyway, so the other 2 questions are, and I actually know the answer to this, but I want to hear what you say about it. One is your favorite text editor and scripting language.
So my favorite text editor is Emacs and has been since like 1987. It's amazing to me, however, that I still have VI muscle memory when I get on a Unix system and need to edit something before Emacs is installed. But yeah, I have been using Emacs for a long time. And my favorite scripting language, it turns out, is Perl. For similar reasons. I started using Perl back in the early 90s, and I just don't see any reason to not use it for everything I do.
Yeah. But by the way, if all goes well, we'll have Allison Randall, who's famous in the Perl world, on next week as well. That would be good. So that's
there's a famous there's a saying that goes that if you're a developer and you blog, eventually you will write your own blogging system. And that is true of me. I wrote my own blogging system, and of course it uses Emacs and Perl.
So, and is that available to anybody? I mean, if somebody says, geez, I really like Phil's
it's in my GitHub repository, which is just under Windley. So I'm sure somebody, if somebody wants
okay.
you could play with it.
We'll have to put that in there too.
To me, in the sense that it's my idiosyncrasies and what I'm willing to put up with. But yeah, I mean, I write HTML raw in Emacs. That's using an HTML mode. So, I'm old school that way.
Well, that's excellent. Well, it has been great having you on here, Phil, and I really appreciate it. I hope we've gone over enough stuff to tempt people to jump on some of the projects you've been involved with. Really appreciate having you on the show.
It was great to be here. Thanks for having me.
Yeah, thanks. So, Shawn, you're still there, I assume.
I'm still here. Oh, yeah, I'm still here.
So
I was patiently listening. Had it gone to me, I would have just seen my listening face and looking at the camera. So I'm curious. I'm curious about wallet software suggestions because I want to play, because playing is the mother of invention. I don't think that's really the the saying, but yeah. that's how all of my projects start, is me playing with something. So,
well, my one-liner on this is invention is the mother of necessity. Like, you see something, now you've got to have it, right? And it's not the other way around. And I thought that was a really clever thing to say until a college professor I knew, who was also a client of my company, said, "Oh yes, Thorsten Veblen." I said, "Who?" Thorsten Veblen said that 100 years ago. So I guess it's a principle, but that's an issue here. I mean, I think you need to see the wallet that you want, and then to write your own or something like that. Like Phil was just saying about, sooner or later, a programmer who blogs is going to make their own blogging software.
I like the idea of using a wallet to, to play with credentials in a system that I might be using, credentials or information or whatever. I personally have very little interest in developing a wallet myself. I don't want to do that because there's already some out there that I'm sure are perfectly fine. So,
yeah, and that's what we want. I mean, it's like nobody wants to make their own browser at this point. Nobody wants to make their own email client. Nobody wants to make any of that stuff because enough of them are available from various sources that you can just do it. I wonder, in the same way as you can do Mutt or Pine in a shell, if you can do this similar thing with a wallet. Hadn't thought of that. If Phil's still there, maybe he could jump in and say yes or no. I don't know. Make it brief.
Yeah.
But
am I live? Can you hear me?
Yeah, you're live. You're still alive. We've kept you alive.
Good.
You're light support in our green room.
Obviously you can get involved in the open source and start from scratch if you want. But if you just want to play around with a wallet and even issue some credentials, one easy way to do that is trinsic.id, like extrinsic or intrinsic, but without the X or the N, just trinsic.id. They have a cloud-based system. You can actually use their system with somebody else's wallet, but you might as well download their wallet. And then they have a cloud-based system where you can go set up and issue yourself credentials on the testnet and just play around with how credentials work and see how all of that goes. And that's a pretty easy way to just experiment. And then, if it all works out, you might say, hey, yeah, I really need to get involved in the code. And then you can dive into the Aries project.
Cool. Appreciate that. Thank you.
That's excellent. So Shawn, since we're even over time here a little bit, so tell me, what do you want to plug? Because you get plugs out of this.
Oh yeah,
plugs.
So I'm gonna plug. It's on my lower third there. I see it right now. YouTube, Shawn Powers with the 0. Yeah, I want to plug that because I've been horribly neglecting my YouTube channel for the past couple months. I have a new job now, and I've been focusing on that. So I need to get back into the YouTube saddle. So yeah, it's great that it's plugged because hopefully that'll be motivation for me to actually do something there. Oh, look at that. That's me.
Yeah. That was I just got that was a text I got from my son, and I meant to have that muted, but there you were. I actually, for those watching video, there was a little sample of your YouTube there. So this is great. Thanks a lot, Shawn, and thanks, Phil. And this has been a very densely packed show. And I really appreciate everybody in the world who's tuned into this. So thanks so much. We're going to have Allison Randall on next week. If all goes well, we'll be talking Perl, whatever else she's working on right now. And we'll see you then. Thanks a lot.